Hello friends, welcome my channel. Today's discussions the geo of analytic functions and pole and singularity. Singularity. Poles and singularity friends. So friends, today's discussions is based on theory and maths. Both I will discuss. At first I will discuss the theory. The value of j for which the analytic functions fj becomes 0 is said to be the zero of fj. If fj is analytic, must remember friends that the analytic functions this is the very important analytic functions because we can get zeros from analytic functions. Friends, analytic means holomorphic functions. Analytic function is called also holomorphic functions. What is analytic functions, friends? I have told in my previous videos lectures based on complex analysis. You know that analytic functions means it is differentiable functions. These functions is differentiable, but and another factor that analytic functions is also satisfied Cauchy-Riemann equations. Cauchy-Riemann equations means ux equal to vy, and uy equal to minus bx. This is Cauchy-Riemann equations. Here equations friends. Analytic functions follows CR equations. Analytic function is also differentiable. Analytic function is also differentiable. Another factor, whatever friends, two another factors, then del f by del z bar equals to 0. Then this function is called analytic friends. I just recapitulate the previous theories. What is analytic functions? So friends, we know that the value of j for which the analytic functions fj becomes 0 is said to be 0 of fj. Is said to be 0 of fj. And if fj is analytic in a domain D, and z0 is a point, z0 may be any point of D, then we can explain fj as Taylor functions. Friends, Taylor functions can be written fj is equal to n equals to 0 to infinity, n equals to 0 to infinity, n is a coefficient. So friends, Taylor equations means Taylor when it is follow Taylor equations, then it is follow these equations. And another factor that a0 equal to a1 and a2 equal to a minus 1 equals to 0, then am does not equals to 0. Then am does not equals to 0. Am at z equals to z 0. A 0 of order 1, m equals to 1. When m equals to 1 friends, then it is the proof that a0 and a1 and a2 and a minus 1 equals to 0 and m does not equals to 0, then is the way we can express the function as a Taylor series. Then we can must remember friends, noted that then we see that a0, a1, a2, an minus 1 equals to 0 and an does not equals to 0. Then friends, whatever I get a 0 of order n, a 0 of order 1 is said to be a simple 0. A 0 of order 1, n equals to 1, then is called simple 0. So when simple 0 means n equals to 1. This is my total definitions of the zeros. Now I will solve some examples. Singularity and nowhere singularity. Nowhere singularity. So friends, before I will discuss that what is geo functions. Now I want to discuss singularity, and why I discuss the singularity, friends? Because noted that singularity is very important, because the zeros is the zero and singularity. The number of zeros we can understand that fj whatever equal, we see that fj equal to 0 for z equals to z0. Then z0 is called singularity. And order also I also discuss how can I get order. So friends, singularity and non-singularity, non-whole singularity. Before that, singularity. What is singularity, friends? Let W equal to fz. Let W equal to fz. So friends, fz is a W is a function of fz functions, and you will see that this is a graph. Okay, this is a graph, friends, and z is a point, and I will get a del. Del is a del. I get a del, and I will. This is a path. This is a portion. If I will get any point, suppose it is z0, is z1. If the function any point somewhere, means this is a somewhere any point between mod of z minus z0 less than del, any point of z minus z0 into del, then we get whatever we get, friends. One is analytic. Any point between any point z minus z0 means z0 is not included, friends. Any point f is analytic, then this function f is analytic. Then this function is called whatever this function is called. This function is z0 is then z0 is singular point. So friends, nowhere singularity and singularity. This is the very very important, because nowhere singularity means no singularity. Nowhere singularity means no singularity. You cannot get any singular point. And so friends, whatever I get, that W equals to fz, and if such that D tends to capital C for complex number, friends. C for complex number is said to be analytic. Is said to be percentage, and z0 belongs to D is said to be singular point. Is said to be singular point if and only if del greater than 0 mod of z minus z0 less than del, f is analytic somewhere. Somewhere means it may be any one of point. It may be suppose z1, z2, z3. This is not analytic. z0 and this positions, this area you will get z1, z2, z3. It's not analytic. But there is just only one point. Maybe only one point, friends. Maybe only one point. Somewhere where, but not at z0. Somewhere, but not. F is analytic, but F is analytic somewhere, but not at z0, but not at z0, then it is, then z0 is singular point. z0 is singular points. I hope I will explain everything. Now I will discuss some example of singular point. So friends, singular point, when I will get singular point, I get that fj, let fj is equal to sine j by j square. Let, and no where singularity means no singular point. No singular point. No one singularity means no singular point. No singularity. Example, here example is fj is equal to j. Fj is equal to j. And this is the singularity point, singularity friends. And singularity is sine j by j square. So friends, whatever I will get in here z equals to 0. Z equals to 0. It is z equals to 0. It is singular. Suppose singularity is two kinds. First and second. First is non-singularity, isolated singularity. First is non-isolated. I write down non-isolated singularity. And second is isolated singularity. This is my total two singularity. One is non-isolated singularity, another is isolated singularity. These are classifications of singularity. So friends, isolated singularities are, one is removable, another is pole, and second is essential. So friends, two kind of isolated singularity, but non-isolated singularity is only one, that is essential singularity. So friends, this is my total classifications of the singularity. One is isolated, another is non-isolated, another is isolated singularity. This is my total two kind of singularities. Now friends, I will discuss removable, pole and essential isolated singularity. Then I will discuss non-isolated singularity, means essential singularity. Essential singularity are classified into two ways. One is isolated, another is non-isolated. So I will discuss each and every one. Okay. Friends, I am just learner and I want to discuss, because as discussions improve our knowledge. Now I will show about isolated singularity. So removeable singularity. Removable singularity. So friends, before the isolated singularities, we need to know that what is the isolated singularity. Okay, isolated singularities meaning. Isolated singularities is same factor friends. If Z0 if such that D tends to C and Z0 is called isolated singularity if and only if mod of z minus z0 less than 10 and we get where f is analytic everywhere the neighborhood where NBD z minus z0 everywhere where NBD of del NBD but it is not analytic at Z0. So friends, it is analytic everywhere, only Z0 point it is not analytic friends. It is not analytic. So X plus the D tends to 0 and C is the complex number and D is domain. So Z0 is called isolated if and only if Z minus mod of Z minus Z0 less than del and F is analytic everywhere everywhere in del and BD means in this NBD everywhere here F is analytic but it is not analytic at Z0. So friends, I hope that I clear about the isolated singularity. Now I will go removable singularity. That the isolated singularities, type of isolated singularities, removable. How can we understand that the singularity is removable? I just give a short note because for CSR net. For CSR net gate, we need to they can ask that which kind of this question, this is the removable singularity or also university examinations. Also university examinations, they can ask that this is removable or not. So in case of removable, then if limit z tends to z0 if j tends to z0 if j is equals to finite, friends, equals to finite. Finite, that means this exists, limit is exist. Limit is exist. Z tends to z0 is finite, then it is removable. Then the function is removable. The function is removable because limit z tends to z0 if z is finite or exists. So must remember this fact. So friends, whatever you will get, you can get the limit z tends to 0. Example, z tends to 0, sine j by j equals to 1. So friends, whatever you can get that if fz is equal to sine j by j and sine j by j, because j tends to 0, sine j by j is equal to 1. So fj, so j equals to 0 at j equals to 0 if z is removable singular. Removable singular. So friends, real analysis, you know that removable is discontinuity. Similarly, in the complex analysis, we get removable singularity. Removable singularity. So friends, same factor that the complex analysis and also real analysis. But real analysis in case we are there is only one line, but complex analysis is complex plane. This is the difference between real analysis and complex analysis. Because complex analysis means you get this plane, complex plane surface. So friends, I hope that I can clear removable singularity, isolated singularity, and three portions. If limit z equals to z tends to z0, if z and equals to finite and exists, then the function is removable singularity, and limit z equals to z tends to 0, then makes this removable. And now again I will discuss pool. I will discuss about pool. My today's discussions is only isolated. Okay, this is the theory is very large. I will discuss more and more because the theory is very large. Let's see that I can, because time is also a very important factor. Because okay, next is pool. Next value is pool. So friends, what is pool? Pool means limit z tends to z0 if z tends to infinity. This is the theory. Limit z tends to z0 if z is equal to tends to infinity, but when limit z tends to z0, z minus z0 whole to the power n if z is equal to 0, then and limit z tends to z0, z minus z0 whole to the power n minus 1 if z equals to infinity. It is also infinity, friends. So friends, when in the case of limit z tends to z0, z minus z0 whole to the power n if z is equal to 0, but you can see that limit z tends to z0 into z minus z0 whole to the power n minus 1 if z equals to infinity, then if z at z equals to 0 then at z equals to z0 if z equals to z0 is pool. Z0 is pool of fz z0 equals to pool of fz space. Must remember z equals to z0 is pool of fz. So friends, whatever you see that z equals to z0 pool of fz. So friends, what is then, and n is order of pool, but must remember that n belongs to capital A. N belongs to capital A. So friends, my example is very simple. What is my example? Example is also very simple, friends. I will discuss what is the example. Example. Example, friends. Example is sine z divided by, I can say also it is sine z by z square. I cannot say. I will say simple. I will take simple factor for fz is equal to 1 by z minus 1 whole square. See that, friends. And now limit z tends to 1 minus z minus 1 whole square equals to whatever you get infinity. Limit z minus 1 and z minus 1 you need to multiply, and z minus 1 whole square will take infinity. Yes. But now if it is whole square, then I will get a finite value. This is the one. Then this is my so given functions order is 2, order equals to 2, and this pole is z equals to 1. Pole is z0 equal to 1. Pole is equal to at pole z equals to z0 is equal to 1. So friends, I get the pole and also order. Now next I will discuss because theory is very important, and next time I will solve CSIR net gate problems. CSIR net gate problem I will solve. So next is essential singularity, friends. Essential singularity. Essential singularity. Let fj equal to e to the power 1 by j. So friends, limit j tends to 0 fj to the power limit j tends to 0 e to the power 1 by j, limit does not exist. Limit does not exist. So friends, limit does not exist. What is the meaning of the limit does not exist? Limit does not exist means this is the line I will draw, and in the context plane, in the real analysis, we see the left hand side and right hand side. Left hand limit and right hand limit, when it is equal, then we can say that limit is exist. Means LHS, we will see LHS equals to RHS. According to the real analysis, but in here it is the complex plane phase. In complex analysis, this is the complex plane. Path may be anything. Path is infinity. Path may be infinity, but limit should be unique. Limit should be unique. Path is infinity, but limit should be unique. Then path is infinity, limit should be unique. Then limit exists. Limit exists. So friends, what is the meaning of the does not exist? This is I say does not exist. Does not exist means limit is not limit should be exist, but limit is, in case of this we get limit is not unique, friends. Limit is not unique. Limit may be this way. This is the path. This should be path. This should be path. This should be path. All are path. This is path. All path, but limit is equal. But in here, when limit is doesn't exist, L1, somewhere L2, somewhere L3, we get different values. So this is the limit doesn't exist. This is the essential singularity of isolated singularity. So friends, thanks for watching, and next class I will discuss non-isolated singularity. Non-isolated singularity. I hope I can clear everything. Next complex analysis video. Next complex analysis video, long essential essential, non-essential, non-isolated, isolated, essential, singularity, plus CSR math. CSR math. Thanks for watching.